Hi everyone. In this video we are looking at the full wave rectifying circuit with a filter capacitor. And I'll show you the bridge rectifier circuit, but the effect of the filter capacitor will be similar for the center tapped arrangement. So I have my bridge rectifier diode arrangement like so. And this side is to ground. This side is to the load resistor, which is also connected to ground. And remember, sometimes you'll see that connected across here, which is exactly the same thing. But if I draw it inside there, it's going to be hard for me to draw the filter capacitor when I add that. So I'm not going to draw it inside there. I'm going to keep it shown externally like that. But since since this ground and this ground are the same point, it is in fact the same thing. Okay, so let's draw the output waveform for this circuit. So it's a full wave rectified circuit. So the negative cycles have been flipped up to the positive, and there are a bunch of just repeating positive cycles now because the negative cycles have been flipped up to the positive. So remember, with the full wave rectifier, the period of one of these is going to be half the period of the original sine wave input, and the frequency essentially then doubles. Now with the filter capacitor put again in parallel with the load resistor, this RL. This capacitor is shown as electrolytic, so I have to orient it with the negative side of this to ground. And what will happen is that capacitor will charge up and discharge and charge up and discharge and charge up and discharge like so. And this is the same effect that happened with the half-wave rectifier, but now that we don't have a gap between positive peaks because the negative half has been flipped up, the capacitor does not discharge as far before it starts to charge up again. And if I were to draw that in the if for the half-wave rectifier, these spots here would be 0 voltage, so the capacitor would continue to discharge before it charged up again. So the full wave rectifier has the advantage there that because the capacitor does not discharge as long, the peak-to-peak ripple here would be smaller, which is good. So that's our V ripple peak to peak. Okay. Oh, and actually one more thing. I mean, something to think about. If you don't see this halving of the period or the doubling of the frequency, because remember that once you put the capacitor in, you don't see the blue waveform anymore. All you see is the pink ripple waveform. And if you're not thinking about frequency, you could have an open circuit diode there somewhere, and the circuit may actually be half wave rectifying, but you wouldn't notice because you're looking still at a ripple waveform from a capacitor, which, shape-wise is going to look the same as the half-wave rectifier. So if you're not, if you haven't pre-calculated what V ripple you're expecting, or you haven't checked that the frequency is twice the frequency of the primary, then you may not notice that you have an issue, right? So that would be checking that frequency doubles is a good thing to check when you have your filter capacitor in there, right? Because without the filter capacitor, if there was something wrong with one of your diodes, you would get these flat spots here and you would notice it right away. But with the capacitor in there, it's not going to be as obvious if you're not paying attention to the frequency. Okay?